Now we are going to discuss what is network. Network. Networks are multiple computers or devices that interconnect able and capable of speaking with each other in a general area, specific area. Or you can further explain it. A network consists of two or more nodes, or you can say PCs, or you can say computers that are linked in order to share resources, such as printers, exchange files, or allow electronic communication. The computers on a network may be linked through cables, that is Cat6, Cat7 cables, that is low LAN cables, Ethernet cables, telephone lines, twisted pair, radio wave, that is wireless through wireless medium, satellites, wireless or infrared beams, again wireless. Classification of network. When we are going to classify our networks, our network is divided into three basic types. One is LAN, that is local area network. Then we have MAN, that is metropolitan area network. And then we have WAN, that is wide area network. So this is the network classification. If you discuss the network classification with respect to the distance, the inter-processor distance processor located in same. So local area network covers within the range of 10 meter to 1 kilometer, that within the within a building, or within the range of 1 kilometer distance. And metropolitan area network covers within a city boundaries, that is to 10 kilometers to within 100-kilometer range, that is within a city boundary. The area network is called metropolitan area network in a city range. And wide area networks, if you communicate between the countries, between the continents, or in the entire planet, that is internet. So we have wide area network, and the internet is also an example of wide area network. LAN. So first of all, we will discuss the local area network, that is LAN. Connects computer within a small geographical location. Look, example, any specific area, locality, town, city, and nearby buildings, near some floors of a building, provided computers with common facilities used within universities, small branch offices, etc. Normally contains a central server system through which all communication and all the devices access through and control and communicate, may restrict some access and resource to some users, that we have some policies and procedures maintained on our server, and all the devices are under the are controlled by the policies defined on the server, so they can only avail the resources allowed. Allowing sharing of common devices, for example printer may connect to some outside network via other means faster than internet, since it is your own area network, that is within your own boundaries. It is inside the building, inside the room, within a room, between rooms. So intranet, your own infrastructure, you are communicating in your own domain, so it is faster as compared to your internet, also known as intranet. LAN is also known as intranet. What is topology? Actually, when we are trying to communicate in a local area network, we design our network in different shapes. So the geometrical arrangement of our computer system is known as topology. that in which geometrical shape we have connected our devices. Common topologies, most common topologies we have are star topology, bus topology, and ring topology. Sometimes we have further one or two more topologies. Sometimes we have tree topology, which is something extended star topology. Extended version of it is a combination of bus and star, and in which we have further multiple switches through which we are instead of devices we start connecting further more switches, and with those switches we can further have some more we have more number of branches, as that in tree we have more number of branches, so it is known as tree topologies. And in this way we can extend the number of devices and pieces we can in our network. We can connect more number of pieces in our network by connecting more number of switches, hubs in a network. So it is extended. We sometimes we call it extended star topology or tree topology. So LAN topologies, basic topologies we have, as I've discussed, star, ring, bus, I already discussed, and we have sometimes another topology named as tree topology. There are one or two more topologies available. For example, mesh topology. Mesh is the combination of any two topologies. So lane network. Lane networks further fall into three categories, also known as lane topologies. As I have already discussed, the most common are star, ring, and bus. Tree is actually the combination of these two, bus and star, or you can also call it extended star. These are some geometrical shapes in which we organize our devices in a network in the form of star. Here we have a switch or a hub through which all the computer devices are going to be connected. This is a ring. One is connected with another, and the second is connected with third, and third is connected with fourth, and fourth is with fifth in a circular ring manner. Bus, all the computers are connected with a center backbone wire. In tree, uh, from one switch we have some devices, and then we have some more number of switch is connected further with switch, and through this switch we can further extend our star topology. So LAN topologies, all the four topologies are based upon some requirements. Star connects computer via central server, or we can call it a central switching communicating device, which is known as sometime it is called switch, and previously we use hub instead of switch. So nowadays we use switch through which all the devices are going to be connected, and that particular switch is connected with a central server through which we are sharing all the resources to our devices. Communication only possible through the server. Then we have ring. In ring topology, all the devices connects our ring topology connects computers end to end in a circular loop, as I discussed in previous diagram. Communication possible from one to another adjacent in a path only. That from one we can send data to other, and from other we can send data to third, and third to fourth, and in this way, in a circular manner, we can transmit the data. Bus, all the computers connected to each other directly. No such communication restriction. All can communicate with each other. So we have a central backbone wire, and all the devices are connected with that particular backbone. Three, computers are connected in a hierarchical fashion. Data flow possible through branches via valid paths. So we are going to further elaborate all these. What is bus? The common Bus topology is one where computers are connected using one or more parallel lines. In this method, each device listens to the bus and examine its data traffic. So you can see this is a backbone wire, main wire. All devices are connected with that particular backbone wire. One popular form of bus network is Ethernet. Its common bus typically is the Ethernet cable. That is, this is the bus main backbone cable, Ethernet cable, which consists of copper, optical, or combination of both. The major advantage of a bus is the ability to add new devices to the network easily. You can easily add new devices over here. A bus topology use one long cable called the backbone, short cables called the drop cables. These are the drop cables which drops towards in a specific devices where through which we can connect the number of devices. Can be attached to the backbone using T connectors. T connectors. The backbone is terminated at both the end. So you can see it is terminated from this side as well and this side as well. Then we have ring topology. In a ring topology, computers are connected circularly. Each computer in the ring can only communicate directly. You can see in the diagram with the computer on either side of it, from this to this or from this to this. If I want it wants to communicate with the device further away, it sends a message that passes through each device in between. So if I want to send a message over here, it first passes from here, then from here to here. Devices in between. All right. So from the number of, if right now we have only one device, so if we have more number of devices, so the message has to be passed from all those devices in order to reach our destination device. IBM's token ring is a variation of the ring topology. So IBM uses token ring topology. You can see a free token is routed around the ring. You can see there is a free token routed around the ring. As it passes around the ring, it pulls. You can see as it passes around the rings. Now it depends that for where is the source and where is the destination. So you can see this ring is passing from one device. It is not this signal, and when it reaches to this device, uh, it is not received at this particular point because this message is not for this device, and then in a similar manner it continues and reach to the destination for uh, because it checks different addresses that which destination this data wants to be transmitted. The source has transmitted this data for this particular destination, and in order to reach that destination, it tries to check all the particular PCs and devices in between the route and reach the finally to the destination. So as I told you before that, if we have more number of devices in between, so that particular data or message has to be passed from all those devices in order to reach the destination. A free token is routed around the ring. As it passes around the ring, it pulls devices on the network to see if they want to transmit data, and when those who want to transmit the data, so when one is transmitting, other is in the position to wait. So star topology uses a central computer that communicates with other devices. So this is a central computer. You can call it hub switch, and the main server is connected with this hub. And through this hub or switch, the network, facilities are provided. Either internet facilities are provided to all these devices. So if this device want to communicate with this device, it communicates via this switch or hub. So star topology uses a central computer that communicates with other devices on the network. Control is centralized. You can see through this centralized hub or switch, all these devices can communicate with each other. So centralized control. If a computer wants to communicate, it has to go through the central computer. That is this is switch or hub or concentrator. The same thing. So the best part of this device is the this star topology is if you want to add some more number of PCs in ring, you have to first eliminate shut down your network, then open the ring, and then you have to add some more number of PCs. But here you can add more number of PCs. These PC devices are just plug and play, so there is no need to shut these PCs network. You just want to add another PC on this if the port is available with on this switch or hub or in the switch or hub. So, and if there are more number of pieces are required, as I told you in the star topology, then what we used to do is in extended star, I can say tree topology, we add some more number instead of these devices, these PCs, we connect some more number of switches like this in some of the ports, and through which we can connect more number of pieces in this manner. So there are further branches came out from main central link, that is the hub or a switch. Previously we use hub. Now these days we don't use hub because hub is a dumb device. When I'm going to discuss with you the peripherals and components we use and the devices we use in network, then I'm going to explain about hub, switch, router, bridge, modem, repeater, all these devices I'm going to discuss in that particular lecture. So tree. You can see in tree topology can be thought of as being a star or the stars network. In a tree network, each device is connected to its own port on a concentrator, that is hub or switch, in the same manner as in a star. So you can see we have further we can connect over here some PCs, or instead of connecting PCs with the main switch, we have multiple switches connected with main switch. And in this way, if we have 10 switches, every switch can give us 20, 12 to 24 PCs. So in this way, if we have 12 or 24 switches over here, with every switch we have 12 to 24 pieces, so we can add as many pieces as we want. If we extend the branches of a star, that it looks like a tree topology, that is we also call it extended star topology. You can see if further over here I came to know that I want to connect further more 40 50 pieces in this switch. So what I'm doing going to do is I am going to, if I want 50 pieces, for example, I am going to connect three more switches in these three ports. Instead of connecting devices directly to this switch, I cannot add many PCs. So what I can do is, if I'm going to add three switches of 24 ports, now I can add with two switches, I can add 48 or 40 PCs. So in this way, I can easily connect 50 pieces using three switches further. So this is how for from one switch we have further switches and branch switch. Then we have further branch with one branch switch. We have further branch switches, and through which we connect as many devices as can, and we can extend our network devices and size of our network. Advantage and disadvantages. Bus topology. First topology we have discussed, that is bus topology. It is low cost to create, less media, low cost to create, but high management cost. Management cost is high because the backbone, if the backbone wire is affected, or if we have any problem in the main backbone wire, then high management cost. Less media use. Goes down does not affect rest. If through tree connector any one PC is affected, other are not going to be affected unless and until the main backbone wire is affected. D- High management cost, difficult to troubleshoot. Yes, and fault, where actual fault exists, it is difficult in this bus topology to identify. All units affected by media failure, as I told you, that if main backbone wire is affected, then in all the devices connected are going to be affected, and there will be no network on any device. All devices are out of the network. Star topology, easy to configure and easy to troubleshoot, as well as all the pieces are directly connected to the different ports of a main central switch or hub. One goes down, it does not affect the rest. More costly, use more media. More costly, uses more media means every system is connected with a separate wire, with the central processing unit, we can call it as switch or hub. So every PC is separately connected with a different wire to the main main central device, switch or hub. So more costly. If hub fails, entire network fails. The over here, the only which is the chances of hub failure or switch failure are minor. The probability, the very the probability of failure of hub and switch are minor. So the only chances of network failure is if the central hub or switch is mm, affected. Otherwise, this is a more fault tolerant network. Hub can become bottleneck. Yes. So these are basic advantages and disadvantages of star topology. Ring topology, cable faults easily identified. It can, because cables are connected in a circular manner, so we can easily track from where the cable has been broken. It can span longer distance. Each host repeats and amplifies the signal. Since if message is transmitted from PC number 1 to PC number 6, so when it reaches from PC number 1 to PC number 2, it repeats and amplifies the signal so that it can reach from 2 to 3. Then 3 again, it is not this that signal, that message is not for 3, so 3 again regenerates and amplifies the signal so that this signal can reach to the device number 4, and in a similar in this manner it can easily reach to the required device, that is device number 6. So it can span at longer distance. Each host repeats and amplifies signal, but disadvantage is more difficult to install, because every time when you want to add any PC and any device in a network, you have to shut down the entire network first, and then you can add any device between any two devices. Media failure on a single unidirectional loop cause common network failure. If any device is affected, the whole network will be down. Then we have these topologies basically are for the local area network, because the in which geometrical shape we have connected our devices in our domain. So these topologies are for the local area network. Then we have some other types of network, or the classification of network, that is main metropolitan area network. We have WAN, that is wide area network. Sometimes we have some more classes you can further find out. When you're going to search on Google, you came to know that there is a PAN, that is personal area network. Then you have a SAN, that is storage area network. I'm not going to discuss in our lecture those, but you can further search that. You have as many area network as you want. So the most common classification of these networks are local area network, metropolitan area network, and wide area network. But if you want to discuss or classify these networks on practical basis, in a technical manner, in a technical point of view, from the technical point of view, then we can say that there are only two networks, LAN and WAN. If you are communicating from the technical point of view, if you are communicating within your own domain, that is from the source to the destination, the resources you are using and the data you are using and the cables you are using, to all these infrastructure belongs to. If you are communicating within your own domain, then we will call it a local area network. No matter you are communicating from Karachi to Hyderabad, but if the wires are the media you are through which you are taking through which you are communicating, or the data transmitted from Karachi to Hyderabad belongs to you, then it is local area network. And if you are communicating from source to destination but not within your own domain, you have to go out from your domain to your service provider domain, and through your service provider domain you have to reach to the Pakistan Telecommunication Authority gateway, and then you are through submarines, you are going through Dubai, you are connecting to the first world countries, that you are not communicating within your own domain. So it comes under the definition of wide area network. But this is not the theoretical definition. These things I have discussed from the practical point of view. That if we discuss with the practical point of view, we have two types of network. One is local area network, that if you are communicating within your own resources and in your own domain, and if you are if you go outside for your own domain and you use other domains in order to communicate from source to destination, then it comes under the definition of wide area network. So here we are discussing some more net- network, that is main. Main is actually metropolitan area network, may connect two or more computers LAN networks together in mainframe systems, conventionally used over large geographical area within the city boundaries on a national level. A metropolitan area network is a network that connects two or more local area network. For example, there is a local area network in a building number A, and there is another local area network in building number B at a distance of 5 to 6 kilometers. And these are two campuses, campus A and campus B. So if we want to connect those campuses, what we require is called MAN, Metropolitan Area Network. So sometimes we call it campus area network together, but does not extend beyond the boundaries of a city. So within the range of a city, if we are communicating with from one building to another building, from building A to building B, it comes under the domain. And under the umbrella of metropolitan area network, a data network designed for a town or a city. Then we have wide area network. Wide area network uh, bridges the global via various communication methods, allows the possibility like internet. Wide area networks, WANs connect network in large geographical areas such as from country to country or the entire world. Dedicated cabling, sometimes we have dedicated links, sometimes we have to communicate via satellite. Uplinks may be used to connect this type of global network. For example, using a WAN, wide area network, schools in Florida can communicate with places like Tokyo. This is an example I have picked from a case study, like Tokyo, in a matter of seconds without paying enormous phone bills. Two users half world apart with workstation equipped with microphones and a webcams might teleconference in real time, or you can say on online lectures we can deliver. So all these things comes under the definition of wide area network, because of the person who is hosting the lecture, it might be possible he is in America, and those who are having those webinar session or the online session, they are in Pakistan. So all these type of communication comes under the wide area network. A WAN is complicated. It uses multiplexers, bridges, routers, so many connect local and metropolitan networks to global communication networks like internet to users. However, a WAN will not appear to be much different than a LAN, but it is more complex that in a LAN mostly we have one router through which we can uh, access the internet from in our domain from the outer domain. In a similar way, when we have lots of routers, lots of devices, connecting devices through which we reach from one source to our destination, which is a far apart from our source, or the computers are further apart, farther apart, and are connected by telephone lines or radio waves or by satellites. All these types of communication, network communication, comes under the wide area network. Any global communication that is between the continents, between the countries, or even between the cities as well. So, controlling authority. When we discuss the controlling authority in our next lecture, we will discuss the different types of uh, servers. I can say network architectures. So, in controlling authority, in a network, that how we control different devices. So a central server supervises all the connecting computers in a network, which are known as, these are three different types of network architecture actually. Server based, one dedicated server, client server architecture, in which one system sharing its resources to other, and then we have a common network architecture, which is known as point to point or peer to peer our network architecture, in which all computers having equal relationships and rights. There is no client and server concept. So in our next lecture we will discuss all these points when I'm going to discuss with you the topic of the heading of client server architecture, client server and peer to peer, or I can say when I'm going to discuss with you the different network architectures. So uh, we will continue all these things in next lecture. So we will stop over here. I am I have completed my this lecture.